If we see keenly on the surface of the earth, there are a number of changes. All the landforms are undergoing continuous change. Some changes are sudden and some changes are very slow. Some changes are being caused by endogenic forces and some changes are being caused by exogenic forces. As you know that the endogenic force comes from the asthenosphere in the form of tectonic forces, while the exogenic forces are caused by climatic factors. Those are climogenic. And our geological history is evidence that where there were oceans or seas like Tethys Sea, now there have come mountain, Himalayas mountain into existence. In the same way, where there were oceans, paleo-oceans in the past, now there are continents, and continents have been replaced by oceans. Thus, all the major landforms are the function of endogenic forces, while minor small landforms like mountains, peaks, valleys are the function of interplay between the endogenic and exogenic forces. Now, let us study today the forces affecting the earth crust. These are continuously at work or process. We can categorize all the forces in two groups. Number one, endogenic or endogenetic force, and second is exogenic or exogenetic force. In endogenic, there are two types of forces. Number one is diastrophic and number two is sudden. Sudden forces show their result suddenly, while diastrophic forces show their result very slowly. In diastrophic force, this is also called plate tectonic force that will be studied separately in Tectonic chapter. In diastrophic force, there are again two types of forces. One is eperogenic, second is orogenic. In eperogenic, we will study the vertical movement of plate, while in orogeny, we study the horizontal movement of the plate. There are plates on the surface of the earth, and in plate tectonic, we will learn that there are oceanic plates and continental plates. They have different weights on asthenosphere, and due to geothermal energy in asthenosphere and radioactive energy in asthenosphere, these plates are moving. Their motion is of two types. One is vertical, up and down, and second is horizontal. Now, let us study first vertical motion. In vertical motion, there are two plates like this, and in it either plate is moving up or plate is moving down, this way, up and down. Now let us see how these plates are moving up. If the plate is moving upward, then it is called emergence. Emergence means coming up. And if plate is going down, that is called submergence. In submergence, land gets down. For example, if we take the example of here North America, eastern part of North America is going up, while the southern part is going down. In the same way, here in India, the eastern part of India means Bay of Bengal is submerging, Why plates emerge and submerge? It is very simple to understand. Suppose these are the two plates, and if one plate is continental, it will be higher. The second one is oceanic, its level will be lower. After rainfall, heavy amount of sediment will be brought down from the higher continental plate and deposited over the lower plate. Lower means oceanic plate. With the result, oceanic plate will subside and it will have pressure. It will exert pressure over the underlying asthenosphere's magma. Thus, that magma will be forced to flow and come below the continental plate. With the result, continental plate will come up, which is called emergence, and there are a number of examples of emergence of rising plate in world. In the same way, if there is emergence, other side there will be submergence, and submergence incidents have also a number of examples. You can very simply understand it by a simple natural example. Suppose a black buffalo goes to take bath in a pond, and a crow is sitting on the back of that black buffalo. As soon as buffalo submerged in the water, then that black crow cries, "Black madam, where are you?" But that black buffalo replies that I have got completely submerged under the water. Then that crow waits for black sister. As that buffalo comes up, the back of that buffalo is seen first. Then black crow sits on the back and asks, "Madam, what you have done?" Then that buffalo replies that I have emerged. Now I think the concept is clear to you what is emergence and what is submergence. You should not be confused between emergence and upliftment. Upliftment is a different process wherein due to collision of two plates, the sediment between the two is forced to come up in the form of folded mountain. That will be cleared later on in tectonics. So these are the two things. Emergence and submergence both are the result of vertical motion in the plate, that is collectively called heterogenic force, which is a type of diastrophic force. Now you should give examples of emergence. Here you are seeing that Newfoundland is emerging at the rate of 0.8 mm per year, Scandinavia 7 mm, Alaska 4 cm per year, and North Sweden is also rising at 9 mm per year. Finland is also rising per year and getting 7 km square of area each year. In the same way, Appalachian Mountain along the east coast of United States of America is also rising at the rate of 6 mm per year, but this rising should not be confused with the orogenic force, but it is not uplifting, rather it is emerging. So these are the examples of emergence, while there are also examples of submergence. Submergence means land is going down and ocean water is covering that land. There are two examples of submergence. One is Gulf Coast to the north of Caribbean Sea, or where the Mississippi and Missouri rivers drain into and deposit a voluminous amount of sediment. Thus, it is subsiding, and a new geosyncline is developing here, where it is supposed that due to tectonic forces, in future a new mountain will come up. In the same way, along the east coast of India, especially where in Bay of Bengal, the Ganga and Brahmaputra system deposit a voluminous amount of sediment that is also a geosyncline, that is subsiding at the rate of 1.2 mm per year, and a geosyncline, say the largest geosyncline of the world, is developing there, and in the coming geological future it is expected that a new mountain will be originated from there. In world, there are some examples of emergence and some of submergence. In emergence, this is Newfoundland that is rising, and here this is Appalachian mountain, it is also rising. Here in Europe, Sweden is rising, and Finland is getting some land that we have already discussed. In the west of North America, this is Alaska, this is also rising. Why these lands are rising or emerging? Let us understand its cause. Here you are well aware of the mid-Atlantic ridge, and the cause of ridge is the spreading of Atlantic Ocean. Why the Atlantic Ocean is spreading? Its cause is the magma from below the oceanic crust is making effort to come up, and it is succeeding also. In that process, the plate margins of West European and North American is also getting force due to the force of magma, and the eastern part of North America is rising, as well as the western part of Europe is also rising. Question arises, why Alaska is rising? Its answer is the same, because here in the mid-Pacific Ocean there is also a ridge that is called the mid-Pacific ridge. Why this ridge? This is also the result of magmatic force from a asthenosphere, and that is pushing up the western part of North America. With the result, this Alaska is also rising up. So these are the areas where the emergence rates have been recorded. Now let us understand, if some part will rise, suddenly some part will subside. There are two examples of subsidence. One is here, Gulf, Mexico Gulf. Why subsiding? Because Mississippi and Missouri drainage systems are bringing down a large amount of sediment and depositing in Mexico Gulf. That's why it is undergoing subduction. New geosyncline is developing here, and in future mountain will come into existence. The same is the case here in the Bay of Bengal geosyncline, that is the largest geosyncline in the world. Ganga and Brahmaputra system are bringing a vast amount of sediment depositing in Bay of Bengal, and this also indicates that a geosyncline is developing, and in geological future a folded mountain will come out of Bay of Bengal geosyncline. After understanding the diastrophic forces, now you can give two answers, short answers to UPSC, and one detailed answer. Detailed answer is this. In diastrophic forces, this is if question is emergenic forces and resultant landform, you should write this much matter. But if short notes are on either emergence or the emergence and its resultant landform, its process, then you will write this much matter. If there is short question on what is submergence, then your answer will be this much, only this short answer, and you will give examples also. Now let us come to know the diastrophic force and its especially the second part, that is orogenic force, wherein we will especially focus on two forces. In orogenic force, there is not vertical movements of plates, rather horizontal movement. We have seen that in vertical movement, two plates have differential motions vertically. One is rising up, other is going down. This is vertical movement. While in horizontal movement, if two plates are closer, then they are moving in opposite direction this way. And in going opposite direction, there is a tension here. But if one plate is moving away from the second, then here tensional forces are caused and resultant landforms come into existence. But it is natural that if one plate will get separated from the other and it is going in opposite direction, then in which direction it is going, certainly there will be one plate and there will be collision between this plate and its neighboring plate. Due to collision, the sediment deposited between the two, where there was a geosyncline, will be exerted pressure, and due to that pressure, the material sediment will come up and there will be folding. There will work compressional force. So, it means in horizontal motion, two results or two forces will work. One, rift or say tensional force, and second was compressional force. That's why if you have to discuss orogenic force in detail, then one is tensional force, that you will give detail of these, and the second is compressional force. Due to compressional force, a number of landforms are developed. This way, this tensional force may be separately asked, where you will write short answer, and this compressional force may be asked separately, where this much matter you should write. Now let us try to understand what is tensional force, how it works, and how many landforms are developed. Now let us try to understand tensional force and tension. Tension is also seen in society, in family. Suppose this one part is father and this part is son. Between the son and father, there may be tension taking some point. Father is expecting son to become IS, then to think about the life friend, while this son, before getting job, is thinking about a girlfriend. This causes a tension, and this tension later on develops into a rift, because the distance between the two will increase. This social phenomena has been attained from the nature. In nature also, this is a major plate and this is the minor plate. Previously, both were closure. Both were attached physically, but magma from the asthenosphere below this one plate pushed up. Due to that, this plate was raised here and a crack developed, very small crack. Here crack, but as magma pushed from below, here that crack became crustal fracture. This fracture widened than the crack. Then that magma started erupting, that pushed up this, and then a fault developed. In this position, this sun, means this plate, may go down because that is not following the rule of society or nature. When this will go down, a rift will be developed and rift valley will be formed. In this rift valley, between the two blocks, water may come, and in this, one may be raised, other may go down. So, there will be vertical irregularity along both the margins of rift valley. What will happen? The raised part will be known as a mountain, not folded mountain, rather block mountain. And if this thing that has happened this side also occurs on the opposite side, then this block is being raised, this block is down, and again to the opposite side of this block, this is also down. Then this one will be called horst. Now you try to understand that one block down, then a rift valley, then one block mountain, then again that rift valley. This phenomena, this landscape is called graben. Here in this model, you are seeing that the block or the land between this higher block and this higher block has subsided. Previously, it was crack, then fault, then it is now in the shape of rift valley, and this is the ridge or say block mountain. And if one block mountain is here, then rift valley, then again block mountain, then again to its opposite side rift valley, this is called continuously graben, but it's one raised part that has two scarps and two block mountains is called here horst. The result of tensional force is number one cracking, then wider than that is crustal fracture, and wider than that is faulting, and with the result block mountains are formed, and then the horst means bounded by two rift valleys is horst and rift valleys formed. The best example of the longest rift valley in the world is in Africa, and the best example of graben is in India. If you see the Vindhyan mountain, that is folded mountain, and its southern scarp is block because to its south Narmada flows in rift. This dispute will be cleared while studying in the topography and geomorphology of India. But here, for common sense, you keep Vindhyan mountain in north, to its south Narmada rift, to its south again Satpura, and to its south again Tapi. This total picture or scenario is called graben. So, these are the result of tensional forces. It means when two parts move apart in opposite direction. But if that sun is moving away from father, certainly that son will meet with girlfriend and there will be meeting and there will be compressional force and new world will come into existence, or say in nature new landforms will emerge. That's why here this is the second part of the horizontal movement, means orogenic process. The second part is called compressional. Here compressional forces are working. In compression, when two plates or two parts of land are coming closer, then in between the two there may be two things. One, some very hard rock, and other, that may be a sedimentary or soft deposition. In both cases, the landscape will be developed in two modes. If two hard land or plates are coming closer, and in between there is one small hard part of land, that mid-lying part of land will get pressure from two sides and that will be bulged. That will be warped. That is called warping. That warping may be in two modes. It may be warped up, that is called upwarping. Due to upwarping, that raised land will be called dome. There are a number of domes over plateau, especially in Ranchi Plateau in India. But that mid-lying part may be pressurized and it may go down. That will be called downwarping. Downwarping examples are also found in different plateau regions of the world. So, a basin is being developed. So, in compressional force, it is warping, and warping is of two types. This is upwarping, wherein dome is formed, and second is downwarping. Now, let us take the other case, that is folding. In folding, between these two hard part of land, there is deposition of sediment or fluvial sediment, and due to coming closer of these two parts, that sediment will undergo pressure and there are no chances of getting that sediment down, rather only coming up. And when that material will come up, this is called folding. Suppose from two sides force is coming this way, then you are seeing that some part is being folded up and some part goes down, and this is called anticline and syncline. This is not warping. Warping is of hard rock, while folding is of soft rock. Now let us understand in compressional force how folding takes place. In folding, there are different types of folds on the basis of mode of the pressure exerted by the two parts or two plates. Suppose my both hands are the plates coming closer and the sediment deposited between the two is rising up. If the force is equal from both the sides, then both the slopes of this uprising fold will be equal. That's why this is called isoclinal fold. But contrary to it, if from one side there is more pressure, but from the other side there is less pressure, then the side having more pressure will have a steep slope, while the less pressure side will have gentle slope. This is also a fold, but called monoclinal slope. Now next thing is that if the force from one side is very high, then this fold is turned and it slips, it falls down, and this is called a recumbent fold. But if force from that side is severe, very much more than the required, then that fold will be broken and it will fall, it will be separated from the main fold and fall in the direction from which force is maximum, and this landscape is called nape. So these are the things which are developed in folds. This is isoclinal fold, both the slopes are equal. Monoclinal fold, one slope is steep from which force is maximum and the other opposite slope is gentle, and if force is too much, then this is called recumbent fold, and if fold is beyond the need, then the folds are broken and thrown away, which are called nape. Now its example is, this is a model showing different types of fold. Here this is a symmetrical. Symmetrical means both the slopes are nearly equal, showing that the force from both sides are equal. While these are the asymmetrical slopes, asymmetrical fold having different types of slopes because of differential forces. And in this way this is recumbent fold, and here this is overthrust, and due to its overthrust it causes severe force from one side, and this broken part is called nape. In fold there is a concept of anticline and syncline. Two terms are there. That's why let us understand these two by a model. Here you are seeing that some part of fold is being raised and two parts are being raised, and one that is lower between the two. So the raised parts are called anticline, and the lower part between the two anticline is termed syncline. What is anticline and syncline? Besides this model, let us try to understand practically. Now you reach the Himalayan region. There is a greater Himalayan range, this one, and to its south, middle Himalayan range, to its south, Shivalik Himalayan range. So greater Himalayan range is an anticline, to its south this Kashmir Valley is syncline. Kashmir Valley is a synclinal valley. There may be a question in UPSC, which type of valley is Kashmir Valley? It is synclinal, it is rift, tectogenic, river. A number of options will be there, but you should answer it that this is synclinal valley. If there is no syncline, then the next option better would be this is a tectonic valley, because syncline and anticline are the result of tectonic forces. So greater Himalaya is anticline, then Kashmir Valley is in syncline, middle Himalaya again anticline, then dunes are in syncline, Shivalik is anticline, and then to its south Tarai is a syncline, that is even today undergoing subduction due to deposition of sediments brought down by a number of rivers from Himalayas. Now one term is anticlinorium and synclinorium. If in one anticline there are a number of series of anticlines and synclines, that is called anticlinorium. But if in a syncline there are a number of small anticlines and synclines, that is called synclinorium. Now take the example of anticlinorium. You take the Greater Himalayas. Greater Himalayas top is not flat. That is naturally having some peak and some pass. Peak is the raised part, pass is the lower part, then peak, pass, peak, pass. Continuous series of peak and pass. So, this is termed as anticlinorium. Greater Himalayas is a good example of anticlinorium. In the same way, Middle Himalayas are also anticlinorium, but Kashmir Valley is example of synclinorium. So, peak and pass and anticline and syncline, there is difference between the two. You may be expected by UPSC to write the difference between the two, and if you have toward Himalayan region, you should have seen it and you can write it with suitable example. And here, suppose there is one question that if somebody wants to travel from China to India, whether he will come to India through a peak or pass. So, answer is pass, not peak. He will not make endeavor to first rise or climb on the peak, then come down. In the same way, if some river travels from China, Tibet to India, that river will flow through this pass and cut it down in a deep gorge. So, these are the examples of anticline, syncline, peak and pass. Now, there is again one complete question by UPSC that discuss the compressional forces and give their resultant landforms. In this case, you will have to write this much. This is one complete question. And in warping, there may be a very short note, while in folding, again short note, but the possibilities are long question. Now, let us come to understand the sudden force. It is also a type of endogenic or endogenic force, but the forces that we have studied, these forces take place or occur slowly. Contrary to it, these forces happen suddenly. For example, you might have heard about the volcano. It is sudden incidence that we will discuss in a separate chapter. In the same way, volcano also comes without information and causes a lot of damage. Landslide occurs on mountainous region in rainy season along very steep slope, and avalanche is also sliding of large volume of ice from snow-covered mountain peaks during winters. And these are the four sudden forces which are put in the endogenic category. But here should be one doubt that volcano and earthquakes are surely endogenic, while this landslide and avalanche are caused by exogenic forces, because during rainy season, when the rocks are hydrated with water, and here during winter season, when there is maximum amount of snowfall, then avalanche occurs and landslide occurs. Then these should be put in exogenic force category. But why here in endogenic? Because in earth movement chapter, we had studied these two as the result of exogenic force. But here, why in endogenic force? Now, let us consider these here independently, because these are the result of the two forces, endogenic and exogenic. For this, we have to here one small story. In past, there was obedient lady, hard-working lady. She was beating rice by pestle. In the meantime, her husband, tired and thirsty, came at door and asked for a glass of water. At that time, the pestle of that lady was up, and because she was very much obedient to husband, she left that pestle in sky and then served the husband with a glass of water. Husband was satisfied. This story was heard by her neighbor. She also ordered her husband that, "Listen to me, tomorrow will come when I will be beating rice with pestle, and you will ask for a glass of water." Her husband said, "Yes, ma'am, I will obediently follow your words." The same happened. When the neighbor's second lady was beating rice with pestle, husband obediently came and asked for a glass of water. That lady, comparing with the neighbor, left the pestle in sky, and she, in place of serving a glass of water to husband, started seeing that pestle in the sky. What happened? You know, that fell on the face of that lady, and that face was being damaged and injured. Why this happened? People say that the first one was very obedient to husband and pativrata, but it is not so. It is the anti-gravity force that was applied in the case of first lady. Anti-gravity force. You can understand what is anti-gravity force. That was not pativrata force, rather anti-gravity force. If you know four forces, first force, second force, third, fourth, then only you can understand anti-gravity force, on which researches are going on in a number of countries, but in India, research on anti-gravity force is being conducted in Bangalore. So, if there is no gravity, pestle or any object cannot fall. That's why, taking the example from this story, we can say that this is the gravitational force that causes landslide or avalanche. In spite of the exogenic force, if there is no gravity force, then these two happenings cannot occur. That's why these two have been put in the sudden forces and endogenic forces. Now, there may be a question on these sudden forces, but the complete questions may be on volcano, earthquake, that we will be studying in the coming video, and small short notes may be on landslide and avalanche. Now let us come to exogenic or exogenic forces, which are of two types. Number one, weathering, and number two, erosion. Weathering means the disintegration and decomposition of a rock at C2. If it is weathered, all the particles are separated, and this is called weathering. Weathering is of two types. Number one, physical or mechanical. Number two, chemical, and then biological. This will be discussed separately because its impact is seen on the distribution and formation of soil in the world. But for simplification, what is weathering and what is erosion? Because erosion is different thing. When the material is being weathered, it is left in situ, and this is by climatic factor like thermal weathering, hydrological weathering, etc. And if material is weathered, it is not being left there. It is being transported by a number of processes which are climogenic, like fluvial process. Water removes that weathered material from one place to other. In the same way, after fluvial process, aeolian process works, means wind, glacial process, glaciers, periglacial process, marine process, and karst process. These are processes that transport the weathered material from higher area to lower area, and this is being deposited either in lower area or in the geosynclines or in the ocean basins. But these are the different processes which are exogenic or climogenic, and these will be studied separately as independent chapter, not collectively. But to understand the difference between weathering and erosion, you can take a simple example. You take a toffee and put it in your mouth. There are two ways of weathering, one physical or mechanical, when you press that toffee between the teeth and that is broken into pieces. This is called physical weathering. Second weathering is of different type. There, teeth are not required, rather only tongue can dilute it chemically, and this is process of weathering. When that toffee is being weathered, then some process will start working, and that will flow or that will be transported by any process, not this process, rather in mouth by the process of water, and that will go down in stomach and it will be deposited, and after that deposition a mountain may come up, means belly may rise. So this we have got, this our body is part of earth, that's why we have got all the natural things which are found in our body. So this is all about the forces affecting the earth crust. You try to keep this chart in mind, because as you have seen, a number of questions may be asked on this board, and this board may be called a key to geomorphology.